Hi everyone, I'm Fight, and I'm going to talk about Python and Glamorous Toolkit. And I have to start by apologizing because I'm not Sven. Sven van Kekenberge, I think that's how you pronounce it, was scheduled to give this talk, I have the misfortune of replacing one of the most prolific contributors to our community. But sometimes remedial at best is all you get. So, right, let's get started. So what we're going to talk about is how to work with Python in GT. We're going to do some inspecting, we're going to do some playing with objects, and then we're going to look at 3 case studies. Now, a few things there you've already seen if you've watched Andre's talk about GT at large. But let's start from the beginning anyway. So I can execute Python code. I can bind variables and so on. In this case, I'm calculating something, and it's going to return me an integer. So this is a Python object, an int. Now, if you look at the debugger, the inspector, you will see that there are 3 things. Here we have a look at the remote object, which is the object in Python, the proxy, which is the object that we have in Pharo that represents that other thing, and the runtime. And the runtime is the thing that executes that code. And we're not going to look at that all too much, but maybe a little bit at some point. Now, this being a primitive type, we also have a way of downloading this into a local variable, so we get a small integer back. So that's kind of nice if you want to work with things. You also get a playground where you can do things with self being bound. This is less interesting maybe for integers, but it is interesting for more complicated objects like datetimes. Right? So this is a datetime. And in this context, self is bound. Datetime in Python is the same as date and time in Pharo. And so when I call time on it, I get back the time component of a date and time. Right? Now, I can look at the print view, and it kind of gives me an overview of this particular object. But print views aren't always enough. And so we're going to look at what we can do with views in a second. Before we do this, I want to show you one little thing. So if we print, right, print in Python doesn't return anything, but it prints to standard output. So how do I get there? And this is where the runtime comes in. Here, we can look at the standard output and see what has been printed since the process has started. So sometimes that's useful because Python code seems to print more than, let's say, Pharo code, right? So sometimes you do need standard output, for better or for worse. Now, if we have something that's maybe a little bit more interesting, a data structure, views get even more important. So in this case, I'm importing what is called a counter that's similar to a bag in Pharo. And I'm filling it with random values. And I get, a kind of useless inspector. It doesn't tell me anything about what's in the bag or counter. It doesn't tell me anything about anything at all, in fact. So what I can do is I can write a view here, even though the class exists. So usually what I would do is, in the definition of my classes, I would write views. How we do that, I'll show you in a second. And I would do it in the class definition. But because Python is relatively flexible as well, we can just attach things to classes later on as well. It's not quite as graceful as in Pharo, but it works. So what I'm going to do is I'm going to import from the gtoolkit bridge, and I'm going to import gtview. As you can see, we have autocomplete in here, which is nice because I can never remember what the import path of the gtview annotation is. Annotations are they look a little bit like pragmas, but they are actually method wrappers. It's a little bit, it's maybe not that important, but the mechanism is a little bit different. So let's see, we call it gt4python collection. I don't have a good name in my head right now. And this is a builder. And then we say, well, I want a list. So if this is not the best Python code or idiomatic Python code, I apologize, but I am writing mostly Pharaoh these days. So I can set a title, right? I can say my view. So if you've ever written a gt4python, then you've seen this sort of thing, right? And so I set a title and a priority. The priority is a number that tells me where in these tabs it will be displayed. I have to give it kind of the items that that we want, which in this case is the keys. And autocomplete acted up there for a second. So I'm going to give it a column. Let's just display the keys for now, right? Because that's the easiest. And I get each here, and I will just display each as is because we already have the keys. I'm going to call this column keys, and then I'm going to return the list, right? And so I will call this and get nothing back. Actually, you know what? I have to attach it to the object, I realized. So I whatever, gt_myView is gt4python collection. And so I'm just adding this to the class. This is nothing fancy in GT or anything like that. This is something I can do in Python. And look at that. So I made a typo in column, so I get an error view. So I can do this again. And now I get the keys. So let's add another column, just for completeness sake, you know, count, right? And we do lambda each self each, right? So, okay. So do the same thing, execute it again. I get the keys, I get the count. Now, if I were to continue, I would sort the keys and so on and get a nicer view. But this is good enough, right? Now we have this view. Now, there is a limitation to this if I do it like this and not in a file. And that is a limitation that comes, unfortunately, with a lot of Python, which is you cannot inspect the source code of something that's not in a file. So if I look at this, I get a method, but I don't get its source code anymore. So this is a Python thing. Unless I use a file for my code, I don't get the source code anymore. All right? So I guess the lesson is, in Python, you still should use files for everything. Now, to complete the examples before we move on to more interesting things, I want to just briefly mention that we can also bind things in Pharaoh and push them into Python. So I printed the file path here, and it's actually, it has worked. Now this is useful. It is unidirectional at this moment. So if I say, for instance here, x is 1, right? And I execute this, and I then open a Pharaoh snippet, x will not be bound, right? The snippet will say nil because in snippets you get undefined rather than, you know, this doesn't exist, but it doesn't actually look up correctly. This is purposely so because we don't always want the proxy objects to be returned, like we do in Gemstone. In Gemstone, it's a little bit more natural because they're both small talks, so it is a little bit more useful usually than here. I can interact with Python proxy objects, just not in snippets. Now, let's look at the debugger. And to work with the debugger well, I have to set the server to debug mode. And then I can actually inspect things. So here I wrote a silly function that just recurses and at some point says, well, we break, right? This is a built-in thing, Python bridge break. And it will break whenever we reach something that is evenly divisible by 10, right? So I execute this and I get a debugger. Now, the first thing that I get is pb break, and then I can step down And again, I don't get the source code because this is in a snippet. But what I do get is I know that n was 10 here, and that n was 9 here, and so on. So, right? And I can continue, I can step into, and so on. Let's continue for now. We get another debugger. What is n going to be now? N is going to be 20, and so on, right? So this is kind of useful. Right. Now we're going to turn server debug mode off because it's going to slow things down a little bit, usually, as debug modes usually do. And we're going to move on to the actual case studies. This case study you've seen in a different iteration. What we're going to do is we're going to look at a CSV file in Pandas. Pandas is a Python library, and it's the de facto standard for data scientists that work in Python to work with larger amounts of data, let's say, whatever large means for them. So the first thing that I'm going to do here, actually before I show you any source code, is I'm going to install the Pandas module. That usually takes a while, but it's there now. So I wanted to make sure that you get the full install experience, even though that's kind of risky with the internet and whatnot. But we then can look at the Python file. You get a somewhat nice view, but we're doing something similar to what we did earlier, where we expand the data frame directly. I'm going to show you something else later, which is what Andre did in his talk a few days ago. But this is one way to do it. You can add things to the data frame. And then I'm going to load this CSV file. I'm not going to look at it because it's very large. You can just believe me that it's very large. And then I'm going to import Pandas here, right? Boom. And I'm going to read the CSV. And again, this is going to take a moment. And then it's going to return me a data frame, which is something that we have as well, but a little bit different. Now, there are no views there yet because I haven't loaded the file in. So what I can do, for instance, is I can import a file, but I can also load the file by just passing the string on to Python. So this is what I'm doing here. I'm telling the application to just give me a string command and put a script in and execute it. And so now if I execute this again, I actually get the columns, the head, the tail, a summary of the table, and so on. This is great. I can already work with data frames a little bit better. But sometimes I know what's in my data frame, and I want to work with that. So if I do this, I actually have that right here, don't I? Yeah, so I don't have to look for it in our book. Our book is very large. So I'm going to do the same thing, right? I have the CSV file again. I am going to ensure that the module is installed. This time it was faster because it was, in fact, already installed. If you want to know what modules are installed at any point in time, you can just look at this. This is kind of a tree view of all the dependencies in the system and all the modules, right? Okay, so we're doing, what are we doing? Right, we're looking at the movie collection now. But instead of using the data frame directly, we're going to use a wrapper class that has the views. And that gives us a way of kind of having a more having an interaction with the data that's a little bit richer, because now I know that, you know, in the data frames there are directors, there are years, there are movies, and so on, and I can actually navigate between those things, right? I have a movie collection here. I still have a movie collection here, but I can also go to the individual movies, right? And then I get a movie back, and this is a little bit nicer to navigate, but this only works if you know the shape of the data. Then you can make a model and so on, like you would do in Smalltalk as well. That's all well and good, but if I click on any of the views, again, I'm greeted with this thing because I can't inspect the frickin' source code because it's all in a snippet. So what you can do is just put it in a Python file. I put it in the working directory, so I can this time a little bit differently import it as a module rather than having to just stream the file in. I can also look, by the way, at my my files with a text editor like this. This one is a little bit more like you would see in your text editor of choice, right? If you were to work with Python regularly. And now, if I go to the same movie collection, it's the same thing. It's just in a file. Now I get the source code. Amazing, right? So now I come here, I look at these things, but maybe I'm a little bit of an adventurer, so I click on how is the source view implemented. Well, this is implemented in Pharo, so I feel right at home. But how do I get to the lines? Oh, we're back to Python. So we're using Python to use Pharo to define our views. I find that kind of interesting. But that's just an aside, neither here nor there. Let's go to the next use case. So in the LLM project, which I'm going to talk about in a few hours, so you have the whatever you want to call that of having me stand here twice. So I'm going to install the TickTokenize library, or rather, so TickToken is the library that OpenAI provides to tokenize things. So you can tokenize things locally. You need to do that because you need to know what things cost when you interact with OpenAI. And the cost of a lot of things is based on the number of tokens. So they give you a nice Python library to tokenize things. And unfortunately, you can't easily just reproduce the code because it depends on their tokenization input, which is based on a training set which they've embedded in their code. So you'd have to pull in the training set, you'd have to convert it into Pharo code, and you have to keep it updated whenever they update, which is a bit of a pain. So instead, what we do when we use tokenization locally is we use the Python code. And we've wrapped the module because we wanted to have views on them. So if I look at this now, I get a nice little view. So this is the tokenized input string. You don't really have to know what it's doing here. I'm going to explain it a little bit more, but basically it just split the string into the individual tokens. I see the token number down here, and it highlights also where things repeat and so on. But you might ask yourself, how does a Python object do that? Because a Python object does not have block. It does not have brick. It cannot make graphical views. So this is not defined in Python at all. It is defined, of course, in Pharo. So how does that work? Well, this is actually a custom proxy object that has a tokenized view. And that tokenized view is just mirrored onto the remote object. Kind of interesting. How does a proxy object work? Well, it doesn't have all that many things, but it does define a Python class. So all you're saying is, when you find an instance of that class in Python, return me that thing in Pharo instead of a regular object. And then I can attach views to that thing, and I can mirror them. Kind of neat. Now I can do the same thing as we do in Pharo, and I get the same thing back, right? But this is now Pharo code, which is a little bit nicer because we have a model for the messages. You can now also kind of see why there's these weird start, separator, and end. I'm not going to go into detail why they're there, but maybe you can kind of glean it from the input. But this thing is Pharo code, and inside somewhere it just calls the equivalent Python code. So this is how we then kind of use the stuff internally, and then at some point you just forget, what it's written in. And as long as you have the appropriate PB application running in the background, everything's fine. Now, that was that. Now we're going to look at some more debugging. And then, I promise, I'll shut up. The first thing is, when you want to sort something, you have to get a list of inputs. Now, this is a random list of numbers. And we have a list of implementations for sorting here. This is LampSort, which is quicksort, but iterative instead of recursive, right? And it's implemented in Python. And so I can look at the implementation here, and it's whatever, it's a sorting implementation. Really, who cares? But I can verify that it works by saying, well, is it sorted after I sorted it? This only works if I have an implementation of sort already available. But when I do, then I do this. Now, what if something goes wrong? What if I have to debug this? Well, I can pop open the debugger, but I also can do something else. And this is why we have 4 implementations. I'm going to go through them one by one. So the first thing that you do is you import this thing, which is gt_trace. Again, this is a annotation, and you put that on everything that you want to annotate. And then you, instead of just calling whatever sort, you reset the signals before you start, and then get the signals that you're interested in. And then you get a bunch of signals for when the method started and when the method ended, right? So this is kind of neat. I see where it started, where it ended, and so on. The tree is more useful because it shows me I called sort, and sort at some point called select interval. And then join intervals was called, and partition was called, and partition called select pivot and swap and so on. If you've ever done quicksort, these names mean something to you. If not, they don't. But it's kind of interesting to go into these signals, right? And you also see, of course, them link back into the source code. Now, this is nice, but can I have custom traces? Yes, you can. So next step, let's add some custom traces because I want to see things inside a function. So you add the telemetry signal event, which is in the same package, and you just give it a message. All right. Now, what do I get if I work with that? Well, you have your custom signals interspersed with the other signals. So you know that when the signal was stashed and when we hit larger than pivot and hopefully smaller than pivot was hit at some point as well, and so on. So you can kind of trace back what happened when. Cool. But I look at this and there's something missing here. I know what's missing, a view. So last implementation, then I'm going to shut up. You don't just need, or you don't just have the ability to have a telemetry signal. Of course, it's a class, so I can subclass it. So in this case, I'm doing a custom signal, pivot comparison, which also has 2 custom accessors and then a view. And so what that buys me, right, is that I can actually go into the code, and now, hopefully, when I look at larger than pivot, and I want to see how much larger, I know what element and what pivot was at that time. So this gives me kind of a trace of what happened, which is not always preferable to a debugger, but especially in relatively complicated applications where you want to see what the sequence of things was, and you don't want to have to keep track of this in a debugger. You want to kind of see the control flow that it went through. This might be a good option. And it's an interesting use case of how you can use Python in GT, I think. Anyway, that's all I have. Those were 3 use cases. So we started with learning a little bit about Python. Then we looked at this, the movie. Then we looked at tokenization. And finally, we looked at a sorting algorithm. So we covered a lot of ground, and if you have any questions, do not hesitate to ask them. Otherwise, I'm going to be here in a couple of hours to give a talk on something completely different. Thank you very much.
For the source code problems of the snippet, so why didn't you just compile a temporary, on-the-fly, temporary, create a file and compile that, so you always have access to the snippet source code, like it's in doit if you do it in Smalltalk, compile a temporary selector.
Right. You can absolutely do that. The reason why we don't do that, I guess, is because we didn't have to. But it would definitely resolve the string issue. It might be a little bit confusing to the user if you have then like a temporary file somewhere, but it's just as confusing or more confusing to not have the source at all. So it is a trade-off to make, yeah. Future work.
What are the plans for the future for this project?
Right. So, I mean, at this point, we're using it in a variety of other projects. But I think what we want to have is a deeper editing capability for users who are using Python. Not everyone always uses a notebook tool flow, and some people want to edit their source code using this and so on. And this is just not good enough. I mean, it's fine. It's great to have, you know, syntax highlighting and an editor. I showed that somewhere here. Like, whatever, syntax highlighting and an editor and a file, and you can expand it and have the directory. That's all great and good, but that's not an IDE. I mean, you want some more integration. So that's, I think, in the future. But that's also a big project again. I mean, a fully fledged IDE for a language, right?
Yeah, another question is, so I don't know how the interface to the Python debugger is. So is it possible, for example, if you have Python code on a Raspberry Pi, where can you remote view into the code is executed there, or is there a network-based bridge, or does it have to be on the same machine?
I mean, the bridge is network-based by default anyway. So if we look at the runtime, it will actually tell you, well, the socket address is localhost, whatever port. So you could go remote. I don't think that we've ever done it, though. So use at your own peril.
Do you see a possible evolution of this work to allow you to work with Jupyter notebooks, like to increase the compatibility, or it can be a compatibility path between Jupyter notebooks and Jupyter notebooks?
Possibly. I think they're fundamentally a little bit different. We do, so the visualizing tokenization, for instance, we did that one just from us, but there was, where is it? This little notebook by Andrej Karpathy on building your own tokenizer that we just kind of took and did stuff with. And showed that it's possible to do the same in GT, but you can already see how messy it is and how what people are doing in notebooks is still printing stuff. So, like, I don't think that we necessarily want to encourage that type of workflow, as mean as that might sound. I think, you know, what you get in a notebook is you get in a Jupyter notebook usually is you get a snippet, and then underneath the standard output and the last thing that was executed stringified. And that's just not good enough, in our opinion.
I don't see any more questions, so thank you.
Thank you very much.